Hello everyone. I'm going to go through the review questions for test 1, which I name as project 1. It's called the test 1 review project. I'm going to give you the answers, the solutions, and explain some of them as well so that you can check your answers against mine. Essentially, you should be working on them on your own, right? Otherwise, it will not prepare you well for the test, just looking at the solutions without having worked on these questions by yourselves, all right? Now, the first question is pretty straightforward. It just asks what are the two major types of statistics, and that's descriptive statistics and inferential statistics. Descriptive statistics is all the measurements that we take on our sample data, all the analysis we do, and so on. That forms the descriptive part of statistics, and the inferential part of statistics is when we draw conclusions, make estimations on the wider population. So, question number 2, it says classify the study as descriptive or inferential. So they've given us a question below with the table containing the data. It says the table below shows the average income by age group for the residents of one town in the year 1998. The average incomes for each age group are estimates based on a sample of size 100 from each group. So these are the average income by age group given arranged in this table, and we have to decide whether it's just a second. I wanted to take out my pen. We have to decide whether this is inferential statistics or descriptive statistics. Now, to help you make a decision, go back and read the question again. In the second sentence, it says the average incomes for each age group are estimate. That's a very crucial key word here, estimates, based on a sample. So whenever they talk about estimates based on a sample, that means they've done inferential study and come up with this data. So these are projections on the wider population, as inferential studies do. So this type of study would be an inferential study. All right, so if you are a bit confused, how do I know whether it's inferential or descriptive, go back and read the question and look for words like estimates and based on a sample and so on. All right. Question number 3, similar question, but this time they say that the table below shows the average income by age group for the residents of one town in the year 1998. All right, so again, it's the same data set, except they don't have that second part of the sentence which says these are estimates and all that. So for this one, we should conclude that it's descriptive statistics because they've just taken actual data from whatever place it may be, and they have just organized as a table and given it to us, right? So this would be descriptive statistics because it doesn't say that these are estimates, or it doesn't say it's based on a sample and so on, right? So that's question number 3. Now question number 4 is related to sampling. So it says, given a group of students, Alan, Brenda, Chad, Dorothy, and Eric, list all of the possible samples without replacements of size 3 that can be obtained from the group. So we have to list all unique combinations, all unique samples of size 3 that can be obtained from a population of 1, 2, 3, 4, 5 people. All right, so that's what they are asking us to do, and we have to make sure that all combinations are listed. If you miss one, then it's not going to be correct. It's going to be incorrect. We have to list all possible samples. So I've used the tree method, which I've already shown in one of the worksheets. I think in the first worksheet we had a similar question, and I explained how we can make sure that all possible combinations are captured by using the tree method instead of doing it in your head. All right, so you're welcome to use this method. I always use this method because I want to get it right the very first time. All right, so since they said size 3, that means we have to draw 3 names randomly. So there are going to be 3 draws. Now in the first draw, I've listed the just the notations, the initials of each name, A for Alan, B for Brenda, and so on. Now if I start with A, then after A I can, in the second draw, this is the first draw, here's the second draw, and this is the third draw. In the second draw I can either get a B or a C or a D or an E, right? B, C, D, E. And then in the third draw, if I've already picked A and B before, then the remaining ones would be C, D, and E, because this is drawing without replacement. If you have selected B or A in the previous 2 draws, you cannot pick them again. That's what without replacement means. So we have C, D, E. Then if you've selected C in the second draw, then the remaining ones are D and E. And then if you've selected D in the second draw, then the one that comes after D is an E. And for the last one, there's nothing after E, so it will always drop off the tree. And then you have to walk the tree to pick up all the combinations. So A, B, C, A, B, C, A, B, D, A, B, D, A, B, E, then A, C, D, A, C, E, A, C, D, A, C, E, and then the last one is not there. So these are all the combinations with A in them. And then once you're done with combination starting with A, you go to the next one, which is B. So start a tree with B and the names that come after that. So if you select B in the first draw, then in the second draw you can either get a C or a D or an E, and then in the third draw, if you've picked a C and a B in the previous 2 draws, you can only get a D and an E. If you had D in the second draw, the only choice left is E, whatever comes after. All right, and then the last one always drops off the tree because it's a combination of size 3 and there's nothing that comes after E. So this is the way you keep going. All right, you will have different trees, and until you don't have any names to fit the size you're looking for, right? We don't need to build a tree with D in it because after D there's only one name, so it will not give us a combination of size 3. All right, so this is how you go about it. This is a complete list, all possible. There should be 10 possible. So when we are working with size 3 from a population of 5, all right, if we want to build combinations of size 3 from 5 names, then it'll always be 10 unique combinations. So all possible samples would be 10. The number of possible samples would be 10, and these are all listed here. So I think that's all this question is asking for, all right, to come up with unique combinations. Now question number 5 is checking whether you understand the different data types in statistics that we will be working with. It says here the following table shows the average weight of offensive linemen for each given football team. So they've listed 5 teams in the first column and their average weight in pounds of the players. And the first question is, what kind of data is provided by the information in the first column team? This column here, this is qualitative, it's the names of the teams. So whenever we have data given to us in the form of names, it's qualitative data or categorical data. And then in the last one, or the second column, the weights, is continuous quantitative or quantitative continuous. However way you want to write it, you do have to say it is continuous, right? Weight is a measurable variable, right? We measure weight, we don't count weight, we measure weight. So that makes it continuous quantitative or quantitative continuous, all right? So that answers these questions. I don't think there's any part to this question. All right, so that answers the first 5 questions in this test. So let's go on to the next one. Now, question number 5 is on organizing data in a frequency table and finding the relative frequencies and so on. So they've given us the data here. On a math test, the scores of 24 students were these are the listed values, and they are not ordered. Now, it says construct a frequency distribution for these scores and complete all the columns. Use 4 classes beginning with a lower class limit of 60. So they've kind of made it easy. They have told us the number of classes that should be used and where to begin from. So it asks us to begin with 60 as the beginning interval, all right? So we have listed over here, all right, 60 to 69. They have asked us to begin from 60. So 60 to 69. Now, they said 4 classes, correct? So how many data sets do we have? 24. All right, 24 divided by 24 divided by 6 would be 4 classes. But instead of making it, making the class width exactly 6, we've made it class widths of 10. All right, because we needed to cover 97 as the highest value, and the lowest value is, I think, 62, correct? 62 is the lowest value. So we have to make sure that the lowest value in the data set as well as the highest value in the data set will fit in these intervals. Therefore, we made it of size 10. So 70, how do we make sure that the class width are all the same in every interval? 70 minus 60, right? That's 10. 80 minus 70 is 10. 90 minus 80 is 10. Likewise, on the other side, 79 minus 69 is 10. 89 minus 79 is 10. 99. So you can always cross-check, all right? Now, again, please do not just do 24 divided by 4 to come up with the class width, because otherwise, if we did that for this problem, then we would not be able to fit 97 in the data set and have the number of classes as 1, 2, 3, 4. All right. So just use your judgment, your logic, and come up with the intervals. But the key point is make sure that all the class widths in each of the intervals, the class widths are uniform. All right, they are all the same. Now, once we have defined the intervals, the next step is to tally. So we go through the list one by one. So 97, right? So we go through this entire list start with 97. 97 is in the where is it, in this last interval. So let's use a different color here. This is for 97, then the next one is 76. 76 will be somewhere here. 73 is the next one. 73 will fit into this interval, 72, 79, and so on. So this is how you walk through the entire data set and tally them. And once you complete your tally, you list in the frequency column, you list the count of the tally. So for the first one, it's 3. So the frequency has 3. Then we have for the second one, 70 to 79, we have 5 plus 5, 10 plus 2, 12, and then 5 plus 2, 7 for the third interval, and then just 2 for the last interval. And then sum up all the frequency values, and that will be your sample size n. And that number must equal to the number of values in the data set. So again, you can cross check to make sure you tallied it right and you have the right frequency values, that all of your data sets were covered in your frequencies. And then the next column has relative frequency. Now, relative frequency uses the formula F over N, right? That's the formula for the relative frequency. It tells us the proportion of values in each interval. So F is the frequency value, correct? F is the frequency value, and N is the sum of all the frequency values. Here we have N. So 3 divided by 24 is 0.125. 12 divided by 24 is 0.5. 7 divided by 24, 0.292. So this is how you go about finding the relative frequency. But the important thing is, please, unless otherwise stated, all your decimals should be up to 3 decimal places. All right, so 0.125. Please do not round it to 0.13. All right, keep it to 3 decimal places unless the question tells you to. Please, by default, always write your answer to 3 decimal places. And then when you add up all the relative frequency values, it should sum up to 1. All right. If you round it up to the second place early on, all right, when you're finding the individual relative frequency values, you will be off from 1. All right. So that's a disadvantage. Do not round up to a lower decimal value. Now, then the next column is class mark. What is class mark? Class mark is the midpoint of each interval. So the way you find your class mark is the lower limit, all right, the lower limit plus the upper class interval, class limit, upper limit, sorry, UL, divided by 2. So 60 plus 69, 129 divided by 2 is 64.5. 70 plus 79 divided by 2 is 74.5. That's how you find the class mark. And then in the last column, I have you multiplying each of these class mark values by the frequency values in the third column, because you can this is the way you can find the mean of the values of mean of the scores from a frequency table. All right, instead of individually adding up all these numbers and dividing by 24, we want you to learn how to find the mean from data given to you in a frequency table. So all you do is find the class mark, which is the midpoint of each interval, multiply each class mark by its frequency values, sum them up, and then divide by n. All right, n 24. Then part B says construct a relative frequency histogram, add a title and label the axis. Make sure you add a title and label both the axis. Otherwise, you may lose points because there are points assigned for that. All right, so this says relative frequency. So you're going to use the relative frequency column values in your y-axis, and over here along the x-axis, instead of showing 60 to 69, which you can do, it's not a problem, it's just that it becomes very cluttered. So I just use the midpoint, the class mark values. But if you write 60 to 69, 70 to 79, all right, if that's how you scale and label the x-axis, that's fine. You still deserve full points for that. And then the relative frequency, the highest relative frequency is 0.5. That's why I scaled the y-axis up to 0.5. And then you have to make sure that these rectangles go up to the relative frequency values along the y-axis. And again, for histograms, the rectangles are all connected. All right, they are all connected. There's no gap between the rectangles, unlike in a bar graph. All right, in a bar graph, you have to leave spaces between the rectangles, but for a histogram, they are continuous. Therefore, you have to make sure that they are connected. One rectangle rides over the other one. All right. And we have labeled it scores for the x-axis, relative frequency for the y-axis, and here's my title. Please make sure whatever question you may be getting that you title it and label the axis properly. The next question says construct a stem and leaf plot for the above. So here's the stem and leaf. You have to divide each, not really divide, but you have to kind of break up each number or each digit of the numbers in the data set. The rightmost digit, so for 97, the rightmost digit would be the leaf, and the rest of the digits to the left would be the stem. All right, and then over here, what do we have? Again, you have to order it in ascending order. Keep that in mind. So our lowest value was 6, I think 62. So the stem values, these are the stem values, these are the leaves. So stem values are listed 6, 7, 8, 9. Then we draw a line to separate the stem from the leaves, and then we list the digits. Again, we are walking through the data set step by step. All right, we are walking through the data set. So for 6, or the values in the 60s would be 62, then there's another 62, and then 5. So we have the leaves as 2, 2, 5. All right, and then 7, we list all the values, 8 and 9. Now it would be a good idea to break it up also, but it's up to you. This is fine as well, but we could have done this as 6, 6, 2 for 6, 7, 7, 8, 8, 9, 9 for the stem. So use 2 rows per stem, and then the first row would be like 2 and 2, and then so 0, anything between 0 and 4 for the leaf goes in the first row for that stem, and then if it's 5 or greater, then it goes in the second row. Likewise for 7, we can just have 3, 3, 3. How many 3s do we have here? 6, 3, 3, 3, and then all the 6s, because that value is greater than 5, greater or equal to 5 if it is, then you list them in the second row for that particular stem. All right, likewise for 8, of course, everything will go in the first one here, and for 9 it'll go here. All right, or both the digits, the leaf digits are 7, so you could do it either way, up to you. Again, make sure you put a label to this. All right, well, not a label, you don't need a label, but put a title to it, that the stem and leaf plot for the scores of 24 students or something like that. All right, so that is the question on, well, there's another part. All right, I forgot about that. So part D says find the mean of the data from the grouped interval above. And that was the reason we had you, all right, find the class mark first of all, and then multiply the class mark with the frequency, and then sum it up. So sigma, this is the summed up value for CM class mark times frequency. Just bring that value 1868.0. all right, that's the way you find the mean. It's sigma CM times frequency divided by n, so 1868 divided by 24, which is comes up to a value of 77.83, and that's the sample mean, all right, for that particular data set. All right. Question number 6 is on finding the measures of central tendency. Listed below are a sample of 10 ammonia fluxes in the first year after Hurricane Hugo. This is the list, all right, of the ammonia fluxes that happened in the air in the first year after hurricane incident. Now, the data 96, 66, 147, as you can see, is not arranged in ascending order, not arranged from lowest to highest value. Now, this is a question on measures of central tendency and variations of the median. So whenever you have to find the median, keep in mind you need to arrange your data in order from lowest to highest value, from the minimum to the maximum value. So that's what I've done here first. I have just taken this data set and I have ordered it from lowest to highest, and in the process make sure that you haven't left out a value, because that's going to affect your answers. And then the next question says find the mean, median, mode of the data. So again, the formula for the mean is sigma x sub I. I just represents the individual values, value 1, value 2, value 3, value 4, and then value I, any value in the middle. So sigma x sub I divided by n. So all you have to do is sum up all the values and divide by 10, because there are the sample size is 10. So 1200 is what it adds up to. 1200 divided by 10 is 120. And I've shown my work here. Now, very, very important. Please show all your work, because there is partial credit assigned to every step. All right. So if you do not show your steps, then you will lose the points for those steps. That's how the grading rubric has been decided by the department. Don't just write the answer, because the answer probably has one or just a fraction of a point of the total points assigned to the question. So if you just write the answer, we want to see whether you have understood the concept behind it, whether you know the process to work it out. That's what we are testing you for. So please make sure you write all the steps in detail, and it is to your advantage, because even if you don't get the final answer right, if there are any computational errors, you still get a lot of points for the steps if those steps are correct. Now, so that's median. I've shown that I've added up all the values and I've divided by 10. Now, for that's the value of the mean. For the value of the median, we of course, need to arrange our data first from lowest to highest, which we've done here. And then we have to find the position where the median would be located. The formula for the position is n plus 1, the number of data set, plus 1 divided by 2. So we have 10 data points here. So 10 plus 1 divided by 2, which is 11 divided by 2, which is 5.5. That means the median will be located at position. This is the position. All right. Make sure you don't write this as the median. No, this is the position, 5.5. So once I have the position, I'm going to walk through my list. So 1, 2, 3, 4, 5, and then 0.5 is between 5 and 6. So what you have to do is you have to take these two values around the position and find their average. So this is what we did here. I listed, I've shown my work again. So starting from 57 to 175, again, make sure you haven't missed a value. And then I went to position 5.5, 1, 2, 3, 4, 5. And 0.5 would be between 5, position 5 and position 6. So this is it's going to be the midpoint between 116 and 147. So you find the average of these two values around that position. So 116 plus 147 divided by 2 is 263 divided by 2 for a value of 131.5. All right, so this is how you find the median, and make sure again you show the process. And then we had it's asking for the mode. The mode is the most frequently occurring value in the data set. So let's look at which one is the most frequently occurring value. So 57, these occur only once. Up to 116, everything occurs once. Then we have 147 occurring twice, correct? 147 occurring twice, and 154 occurring twice. So our answer for the mode should be 147. Right, let's use this. 147 and 154. There are two modes in this data set. Two values occurring more than the others. All right, more frequently than the others. Part B says find the quartiles and list the 5-number summary. All right, 5-number summary is comprises of the 3 quartiles and the minimum and the maximum value. All right, but we need to find quartile 1 and quartile 3. Quartile 2 we already found, it is the median. All right, so we have to find quartile 1 and quartile 3. So to find quartile 1, you have to look at the first half of the data set. So first half, the median, right, this particular median divides the data set into 2 equal parts. So to find Q1, you're essentially finding the median of this data. All right, so it would be 88, correct? So how many values do we have in the first half of the data set? 1, 2, 3, 4, 5. So if you want to go by finding the position, would be 5 plus 1 divided by 2, which is 3, right? 6 divided by 2 is 3. So that means the value in the third position would be quartile 1. So let's walk the list. 1, 2, 3, 88. And that's how I got the 88 for quartile 1, right? Then for quartile 3, you have to look at the right half of the data. So that means, let's use a different color. Yeah, this part of the data set, the right half of the data set, starting from 147. So how many do we have here? 5. 1, 2, 3, 4, 5. So again, for the position for quartile 1, position would be 5 plus 1 divided by 2, which is also the third position of the right half. So you have to start from 147. So 1, 2, 3, 154. So 154 represents our quartile 3. Now it's very important that you find your quartile 1 and quartile 3 correctly, because that's going to affect the rest of your answers when you find the IQR, the interquartile range, and then the upper limit, the lower limit values, and answer the rest of the questions. All right. Now, if over here in this data set, because we had an even number of values, the data set split, the median really split it into two equal parts. However, if we had an odd number of values, then the median would fall right at or right on a value in the data set. In that case, you just count your median value twice. Count it as a part of the left hand of quartile 1 as well as quartile 2. All right. So this is how we go about finding the 3 quartiles, and then quartile 2 is nothing but the median, which we've already found previously. And then list your 5-number summary, starting with minimum value is 57, quartile 1 88, quartile 2 131.5, quartile 3, and then the maximum value was 175. Now it asks us to find, or rather sketch, a box plot. For the box plot, you just have a horizontal line. Make sure you scale the horizontal line correctly, and of course add a title. All right, a title is missing in this solution. Please make sure you put in a title. First indicate your quartiles. All right, quartile 1, quartile 2, quartile 3. I label them also the values, and then connect the quartiles with a box. So vertical lines first, and then connect it as a box, and then the minimum value and the maximum value is connected using what's called a whisker, a straight line from the minimum value to the box, and then the maximum value to the box. All right. Now, if after answering the rest of the questions, rest of the parts of this question, we find there are any outliers in the data set, then you have to indicate the outliers with asterisks. All right. If there is an outlier at the lower end, indicate it with an asterisk. If there's one at the upper end, then indicate it with the asterisk. And in that case, just use the lower limit and the upper limit values instead of the minimum and the maximum values. All right, in your box plot. Okay, so next part says find the interquartile range, upper and lower limits. IQR has its formula Q3 minus Q1. That's why it's very important that you find the correct values for Q3 and Q1, because when you find the IQR and if it's wrong, then your lower limit will be wrong, your upper limit will be wrong, then your data point, this question where it asks what are the potential outliers, that will be wrong, and so it'll affect the rest of your questions. So just double check and make sure you are finding the values of the quartile correctly. So Q3 minus Q1 is 154 minus 88, 66. The lower limit formula is Q1 minus 1.5, which is a constant value, times IQR. Okay, a very common mistake that I should point out is that students sometimes just do Q1 minus 1.5 and then multiply the answer by 1 IQR. That's wrong. Please, you have to follow the order of operations, all right, because that's a very costly error. All right, and especially at this stage, if we've come through all the algebra courses, you should at least know the order of operations. So I'm going to surround this with brackets. First, you have to perform the multiplication and then subtract it from quartile 1. And same thing for upper limit, but for the upper limit, the formula is Q3 plus 1.5 times IQR. Again, make sure you are performing the multiplication first before you add it to quartile 3. So here are the calculations, yeah, and here are the answers. Lower limit minus 11, upper limit 253. All right. Again, make sure that you perform the calculations right. Okay, so part D says, are any of these data points outliers? Which ones and how do you know? So it says for a data point to be a potential outlier, the value must be less than the lower limit or greater than the upper limit. So how do you know? That answers the, to answer this question, the first sentence answers or explains how we would know whether some value is an outlier or not. So for a data point to be a potential outlier, the value must be less than the lower limit or greater than the upper limit. Since there are no values less than the lower limit of minus 11 or greater than the upper limit of 253, we can conclude there are no outliers. So in order for a value to be a potential outlier, it has to be less than the lower limit or greater than the upper limit. All right, so our values start from 57, right, at the lower end. So 57 is not less than minus 11, so there's no potential outlier at the lower end. At the upper end, it's what is the highest value we had? 175, right? 175 is way less than the upper limit value of 253. So we don't have any potential outliers based, and we have explained it in the first sentence. That's the reason we came to that conclusion. And then part E says, does the data appear symmetric, left skewed or right skewed? How do you know? Now, in order to answer this question, you have to look at the mean and the median values and compare. If mean is less than median, then the distribution is left skewed. So mean less than median, that means mean falls to the left of the median. All right, so that makes it a left skewed distribution. If mean is greater than the median, it would be a right skewed distribution. If mean and median are pretty close, all right, it won't be exactly equal. If they are equal or if they are fairly close, just off by a few decimal places, then it's symmetric. All right, it would be symmetric. So you have to remember this rule. Mean less than median means mean is to the left, right? If mean is to the left of the median, then it's left skewed. If mean is greater than median, that means mean is to the right of the median. Right? Okay, so that would make it a right skewed distribution, and if they're equal, then it's symmetric. As simple as that. Okay, so that was the question on variation of the median and the measures of central tendency. The next question is on finding the standard deviation. So I think I'm going to make this the third part of this video, or the second part of this video. All right, otherwise it'll get too long. So the solutions will be posted in 3 parts. And then I'll do the third part with all the probability questions. All right.